Hello aspirants, welcome to Magic World of Physics. In this video, we're going to discuss about some questions from VSSC Scientific Assistant Physics exam. Without any further delay, let's get started. The first question is, the metacentric height is given as the distance between. Metacentric height is defined as the distance between the center of gravity g of a floating body and the metacenter. The metacenter is a point where the line of action of force of buoyancy intersects the original vertical central line of the body when it is tilted by a small angle. So this distance is a key measure of the initial stability of a floating body. So the answer is the center of gravity of the body and the metacenter. The next question is, which of the following exhibits non-Newtonian flow behavior? Here the answer is blood, because a Newtonian fluid has a constant viscosity regardless of the shear rate. Water, air, gasoline are the examples of Newtonian fluids. A non-Newtonian fluid's viscosity changes under stress or time. So here the answer is blood. Next question is, name the Swedish environmentalist who led the Fridays for Future movement. It was Greta Thunberg, a Swedish environmental activist, who started the Fridays for Future movement. It is a global climate strike initiative, and she began protesting outside the Swedish parliament in August 2018, and it inspired students worldwide to participate in similar strikes. Next question is, which of the following is true regarding fluid viscosity? We know viscosity is the resistance of a fluid to flow. For liquid, viscosity is due to intermolecular forces. As temperature increases, kinetic energy increases, and it allows them to overcome these attractive forces more easily and flow more freely. This results in the decrease in viscosity with increasing temperature. So as temperature increases, viscosity decreases. Next question is, the Carnot cycle is a rectangle in dash diagram. Carnot cycle, which consists of two reversible isothermal and two reversible adiabatic processes, is represented as a rectangle in the temperature entropy diagram. So we can say that the answer here is the TS diagram. We know in PV diagram, Carnot cycle is more complex shape with curved lines. Next question is, what is the unit of measurement of entropy? We know delta S is equal to Q by T. We know the unit of heat is Joule and the temperature is Kelvin. So the unit of entropy is Joule per Kelvin. Next question is, name the astronaut who set the record for longest space flight by a woman. The answer is Christina Koch. Christina Koch holds the record for the single longest spaceflight by a woman, spending 328 days in space. Peggy Whitson holds the record for the most cumulative days in space by a woman with 665 days across multiple missions. The next question is, the external surface of a wall of 3 meter high, 5 meter wide and 0.5 meter thickness is at a temperature of 2 degrees Celsius. If a heat loss of 150 watt from the room is measured across the wall, find the inner wall temperature. Here the thermal conductivity of wall material is 1 watt per meter Kelvin. Here height and width are given. So area is equal to H into W, that is equal to 3 into 5, and this is equal to 15 meters square. And here T external is equal to 2 degrees Celsius plus 273.15, that is equal to 275.15 Kelvin. And we know that by the Fourier's law of heat conduction, Q is equal to K into A into delta T by L. Rearranging this, we can write delta T is equal to QL by K into A. Here K is the thermal conductivity. That is delta T is equal to 150 into 0.5 divided by 1 into 15. That is equal to 75 by 15. This is equal to 5 Kelvin. So as heat is lost from the room, the inner temperature must be higher than the external temperature. That is, inner temperature is equal to external temperature plus delta T. That is equal to 275.15 plus 5. That is equal to 280.15 Kelvin. The next question is, the temperature of a surface with 0.2 meter square area is 17 degrees Celsius. Calculate the wavelength corresponding to the maximum monochromatic emissive power. Here the temperature is 70 degrees Celsius. Converting it into Kelvin, we can write temperature is equal to 70 plus 273.15. This is equal to 290.15 Kelvin. Then by applying Wheel's displacement law, we can write lambda max T is equal to B. That is lambda max equal to B by T. That is lambda max is equal to 2.898 into 10 power minus 3 divided by 298.15 Kelvin is equal to 9.988 into 10 power minus 6 meter. That is, converting it into micrometers, we can write lambda max is equal to 9.988 into 10 power minus 6 meter into 10 power 6 micrometer divided by 1 meter, and this is equal to 9.98 micrometer. So it is approximately 10 micrometer. So this is the answer. Next question is the critical temperature of water is dash. Here the answer is 647 Kelvin. The critical temperature of a substance is the temperature above which a distinct liquid phase cannot exist, regardless of the pressure. For water, this value is 647.096 Kelvin, that is 373.946 degrees Celsius. And the other options mentioned are 273.16 Kelvin. It is the triple point of water. And the other are 245 Kelvin and 743 Kelvin. It is not a standard physical constant for water. So the answer is 647 Kelvin. The next question is, which mineral is commonly called as fool's gold? The answer is pyrite. Pyrite is commonly referred to as the fool's gold because its shiny yellowish appearance is often mistaken for real gold. It is an iron sulfide mineral. Unlike gold, pyrite is much harder, more brittle, and has lower density. Halite is a rock salt and cinnabar is a mercury sulfide. Magnetite is an iron oxide and a common magnetic mineral. So here the fool's gold is pyrite. Next question is, with which phenomena is the term ultraviolet catastrophe related? The ultraviolet catastrophe was a failure of the classical physics to explain the blackbody radiation. The classical Rayleigh-Jeans law predicted that an ideal blackbody in thermal equilibrium would emit infinite energy at the ultraviolet and higher frequencies. This prediction was incorrect and led to the development of quantum mechanics. So the answer is blackbody radiation. Next question is, who was the first person to classify stars according to their brightness? The answer is Hipparchus. The Greek astronomer Hipparchus was the first person known to have systematically classified stars according to their apparent brightness. He created a catalogue of about 850 stars and introduced a magnitude system where the brightest stars were assigned magnitude 1 and the faintest visible to the naked eye were magnitude 6. This system with modifications is still used today. Next question is, name the famous book that ultimately led to the widespread ban of DDT and many pesticides. The answer is Silent Spring. It was written by Rachel Carson and published in 1962, detailed the harmful effects of indiscriminate use of pesticides like DDT on the environment and wildlife. The book is widely credited with catalyzing the modern environmental movement and led to increased public awareness and concern. So the answer is Silent Spring. The next question is, what is the SI unit of radioactivity? Here the answer is becquerel. Becquerel is the SI unit of radioactivity defined as 1 disintegration or decay per second. It is named after the French physicist Henri Becquerel, who discovered radioactivity in 1896. The curie is the another unit of radioactivity. It is not an SI unit. 1 curie is equal to 3.7 into 10 power 10 becquerels. Next question is, which is the strongest of the 4 fundamental forces? The answer is nuclear forces. The 4 fundamental forces of the nature are strong nuclear force, electromagnetic force, weak nuclear force, and the gravitational force. The strong nuclear force is the strongest of these, responsible for binding protons and neutrons within the atomic nucleus. In contrast, gravity is the weakest of all fundamental force. The next question is, who invented the refracting telescope? The answer is Hans Lippershey. The first refracting telescope was invented by the Dutch spectacle maker Hans Lippershey, who applied for a patent for the device in 1608. Although Galileo Galilei is often Associated with the telescope, he improved upon the design and was the first to use it for the significant astronomical observation, not invented it. Next question is the measurement technique that can be used to measure the distance between the Earth and the Moon is dash. The lunar parallax and the geometry of the lunar eclipse have historically been used to measure the distance between the Earth and the Moon. So the answer is both A and B. The next question is the value of one astronomical unit. Astronomical unit is the average distance between the Earth and the Sun. So it is approximately 1.495 into 10 power 11 meter. The next question is the equipment used to measure the heat of combustion of a particular reaction. The answer is bomb calorimeter. Bomb calorimeter is a scientific apparatus specially designed for measuring the heat of combustion. It is typically measuring the solid or liquid fuels. The process involves the burning of a sample in a sealed high pressure container filled with oxygen, and the heat released is absorbed by the surrounding water, allowing for the calculation of the heat of the reaction. The next question is when was the first sounding rocket launched from Tumba, Kerala? The answer is 21 November 1963. The first sounding rocket, a Nike Apache, was launched from the Tumba Equatorial Rocket Launching Station in Kerala on November 21, 1963, marking the beginning of the Indian space program. The station, located near the Earth's magnetic equator, was established that same day. Find the odd man out. Here the answer is Professor Nitish Dhawan, because Professor M.G.K. Menon, Dr. G. Madhavan Nair, and Professor U.R. Rao were all the chairman of the Indian Space Research Organization. Professor Nitish Dhawan was not a chairman of ISRO, so the answer is Nitish Dhawan. The next question is the rocket that was used to send man to moon is dash. The answer is Saturn V. Saturn V was a powerful three-stage super heavy lift rocket developed by NASA specially for the Apollo program to send humans to the moon. It was the only launch vehicle to have carried humans beyond low Earth orbit. The first mission to land astronauts on the moon, Apollo 11, was launched using a Saturn V rocket. The next question is the light from the sun reaches us in nearly dash minutes. Here the answer is 8 minutes. The light travels at a finite, very high speed. The average distance between the sun and earth is about 150 million kilometers. By dividing this distance by the speed, that is 300,000 km per second, we get time. That is time is equal to 150,000,000 km divided by 300,000 km per second, and this is equal to 500 seconds. Converting this to minute, we can write this is equal to 8.3 minutes or 8 minutes 20 seconds. The next question is out of the following pairs, which one doesn't have an identical dimension? Here we need to find which option doesn't have an identical dimension. So for option A, the moment of inertia has the dimension ml square, moment of force, that is torque, have the dimension ml square t raised to minus 2. These are not identical. Then the next option, work and torque, they both have the same dimension, that is ml square t raised to minus 2. Then option C, angular momentum and Planck's constant, they also have the same dimension ml square t raised to minus 1, and for impulse and momentum the dimension is ml t raised to minus 1. So the answer is moment of inertia and moment of force. The next question is the rainbow is caused by which of the following physical phenomena? Here the answer is refraction and internal reflection. Rainbows are formed by the combination of physical phenomena including refraction, dispersion, and the internal reflection of light within water droplets. When sunlight enters a water droplet, it gets refracted and dispersed into its component colors. This light then undergoes internal reflection of the back of the droplet. Finally, as the light exits the droplet, it is refracted again. The combined effect of these two processes creates the spectrum of light observed as a rainbow. The next question is the inelastic scattering of the photons by matter is dash. The answer is Raman effect. The Raman effect is the inelastic scattering of photons by matter. In this process, the scattered photons gain or lose energy from the molecules of the material, resulting in a change in their frequency. The next question is the dimension formula for surface tension. So we know that the surface tension T is equal to F by L. That is, the dimension formula is ml t raised to minus 2 by L, that is equal to m t raised to minus 2. So the answer is m t raised to minus 2. The next question is the Mangalyaan was launched by which mission? Here the answer is PSLV C-25. The Mars Orbiter mission or Mangalyaan 1 was launched by ISRO on November 5, 2030. The launch vehicle used for this mission was PSLV rocket. The next question is which is the Autonomous Institute for Atmospheric Science Research funded by the Department of Space? The answer is NARL. The National Atmospheric Research Laboratory is an autonomous research institute funded by the Department of Space, Government of India to perform front-end research in atmospheric science. The next question is which of the following is not a correct match of unit? The energy measured in the British thermal units BTU and the Newton meters Nm, which are both correct units of energy. The dynamic viscosity is correctly measured in meter square per second. The SI unit of specific heat capacity is joule, kilogram raised to minus 1, Kelvin raised to minus 1, which can also be expressed as meter square second raised to minus 2, Kelvin raised to minus 1. But the option given in B is m square by s square Kelvin or m square second raised to minus 2 Kelvin, which is dimensionally incorrect for specific heat capacity as there is a missing term kilogram raised to minus 1. So the answer is specific heat capacity, option B. The next question is which of the following defines the total emissive power of a black body? The answer is Stefan-Boltzmann law. It states that the total emissive power, that means the total energy radiated per unit surface area per unit time of a black body, is directly proportional to the fourth power of its absolute temperature, that is E is proportional to T raised to 4. Next question is how many minimum number of elastic constants are required to describe the behavior of isotropic materials? Here the answer is 2. For an isotropic, homogeneous and elastic material obeying Hooke's law, there are only two independent elastic constants required to fully define its elastic behavior. These are typically Young's modulus and Poisson ratio. Other constants like shear modulus and bulk modulus can be derived by the relation E is equal to 2G into V plus nu, where nu is the Poisson's ratio, E is the Young's modulus, K is the bulk modulus and G is the shear modulus. Next question is for a square block of mass m kept on a rough wedge inclined at an angle theta, the coefficient of friction mu between the block and wedge is given by dash. When the block is sliding down on a rough inclined plane, the forces acting on it are the gravitational force, the normal force and the force of static friction. So the block is in equilibrium. So we need to resolve the gravitational force into the components parallel and perpendicular to the incline. The component parallel to incline is mg sin theta and perpendicular to incline is mg cos theta. For equilibrium perpendicular to the incline, the normal force balances the perpendicular component of the gravity, that is n is equal to mg cos theta. For equilibrium parallel to the incline, the static friction force balances the parallel component of gravity, that is Fs is equal to mg sin theta. At the point of impending motion, the static friction reaches its maximum value, that is Fs maximum is equal to mu1, where mu is the coefficient of static friction. Setting the maximum frictional force equal to the parallel component of gravity, we can write mu1 is equal to mg sin theta, and substituting the value of n here, we can write mu into mg cos theta is equal to mg sin theta, that is mu cos theta is equal to sin theta, that is mu is equal to sin theta by cos theta, that is mu is equal to tan theta. This theta angle is the angle at which the block begins to slide and is also known as the angle of repose. Next question is Kepler's third law for a body moving in an orbit of semi-major axis A with period t is given by which of the following expression? Kepler's third law, which is also known as the law of period, states that T square is proportional to A cube. So the answer is T square proportional to A cube. Next question is, find the frequency and the wavelength of a photon with energy 13.2 into 10 power minus 19 joule. Use the speed of light as 3 into 10 power 8 meter per second, and the Planck's constant is equal to 6.6 into 10 power minus 34 joule second. So here we know that E is equal to H nu, that is nu is equal to E by H. Here E is equal to 13.2 into 10 power minus 19 joule, and H is equal to 6.6 into 10 power minus 34 joule second. So nu is equal to 13.2 into 10 power minus 19 divided by 6.6 into 10 power minus 34, and this is equal to 2 into 10 power 15 hertz. That is, this is equal to 2 petahertz. We know C is equal to lambda nu, that is lambda is equal to C by nu. So lambda is equal to 3 into 10 power 8 divided by 2 into 10 power 15, and this is equal to 1.5 into 10 power minus 7 meter. So multiplying this with the 10 power 9 nanometer, we get it as 150 nanometer. So the answer is 2 petahertz and 150 nanometer. The next question is, which of the following principle is used to measure the speed at which distant stars are moving towards or away from Earth? Here the answer is Doppler effect. Doppler effect is a change in the frequency or wavelength of a wave in relation to an observer who is moving relative to the wave source. When a star moves towards Earth, its light waves are compressed, and that leads to blue shift. When it moves away, its light waves are stretched, causing a red shift. Astronomers measure this shift to determine the star's radial velocity, that is the speed towards or away from Earth. The other options given us the Rayleigh law of scattering. It is used to explain why the sky is blue, not stellar speed. And the other option is the Newton's law of motion. It is the law of motion that describes the relationship between the body and the forces acting upon it. It doesn't measure the stellar speed. And the other option is the Kepler's law of planetary motion. It describes the motion of the planet around the sun, not the speed of the distant stars relative to Earth. So the answer is the Doppler effect. The next question is, which of the following best describes the stress-strain diagram of a perfectly plastic material? A perfectly plastic material is defined as one that deforms permanently and continuously under a constant non-zero stress. This means that once the yield point is reached, the material will continue to strain without any further increase in the stress. On a stress strain diagram where the stress is plotted on y-axis and strain on x-axis, this behavior is represented by a straight line parallel to the strain axis at a constant non-zero stress value. The next question is, force on an object is given in terms of time t, distance x, velocity v by the following relation: F is equal to axt plus root b v square plus c divided by d plus v. What are the units of a, b, c and d? This can be solved by the principle of homogeneity. Here F is equal to axt plus square root over bv square plus c divided by d plus v. According to the principle of homogeneity of dimension, each term in the equation must have the same dimension as force. The dimension of force is ml raised to minus 2. And we know the unit of force is Newton or kilogram meter per second square, and the unit of velocity is meter per second. The first term in the equation is axt. The dimension of axt should be equal to f. That is, a into x into t is equal to f. So here a is a constant, then the unit of x is m and the unit of t is s, the unit of f is kilogram meter per second square. Therefore a is equal to kilogram meter per second square divided by m into s. Therefore the unit of a is equal to kilogram per second raised to 3. Similarly, the dimension of the second term is also equal to the dimension of force. That is, square root over bv square is equal to f. Squaring this, we can write bv square is equal to f square. That is, b into v square is equal to f square. So we can write the unit of v as meter per second, then whole square, and this is equal to kilogram meter per second square, the whole square. This is equal to b into meter square by second square. This is equal to kilogram square m square by second raised to 4. Therefore, b is equal to kilogram square meter square by second raised to 4 divided by meter square by second square. Therefore, The unit of B is equal to kilogram square by second square. Then we need to find the unit of D. In the denominator, the term given is D plus V. D and V should have the same unit, and this is equal to meter per second. The unit of C divided by D plus V is equal to unit of F. That is, the unit of C is equal to unit of F into unit of D plus V. We know that unit of D plus V is equal to V. That is, C is equal to F into V. That is, C is equal to kilogram meter per second square into meter per second. That is, the unit of C is equal to kilogram meter square by second raised to 3. Therefore, the unit of A, B, C and D are kilogram per second raised to 3, kilogram square by second square, kilogram meter square by second raised to 3 and meter per second. The next question is, the emission of electrons upon incidence of light is termed as dash. Here the answer is photoelectric effect. It is a phenomena where the electrons are emitted from a metal surface when light is shone upon it. And we know the Joule-Kelvin effect or the Joule-Thomson effect describes the temperature change of a real gas or liquid when it flows through a valve or porous plug. And also the Tyndall effect is a scattering of light by particles in a colloid or suspension. And the Thomson effect is a thermoelectric phenomena involving the heating or cooling of a current-carrying conductor when temperature gradient is applied. The next question is, the thermionic current is proportional to dash. Here the answer is T square. The magnitude of the thermionic current I is directly proportional to the square of absolute temperature T of the emitting surface. This relationship is described by Richardson-Dishman equation, which states that the saturation thermionic current density J is given by J is equal to AT square e raised to minus 5 by KT, where A is the Richardson constant, phi is the work function of the material, K is the Boltzmann constant. So here the current is proportional to T square. Next question is, let mu 0 and epsilon 0 be the permeability and permittivity in free space. Then the dimension of 1 by mu 0 epsilon 0 is dash. We know that C is equal to 1 by square root over mu 0 epsilon 0. That is, C square is equal to 1 by mu 0 epsilon 0. The speed of the light C has the dimension Lt raised to minus 1. Therefore, C square has the dimension L square T raised to minus 2. That is L square by T square. Therefore, the dimension of 1 by mu 0 epsilon 0 is equal to Lt raised to minus 1 the whole square or L square by T square. That the answer is option A. Next question is, in a radar, PR is a returned echo powder detected by the receiver of a radar from a given target at a range R from the radar. When the target moves away from the radar, PR will decrease by dash. Here the power received by the radar receiver from a target at a range R is described by the equation PR is equal to PT G square lambda square stigma divided by 4 pi the whole cube into R raised to 4, where PT is the transmitted power, G is the antenna gain, lambda is the wavelength, stigma is the radar cross section of the target. For a given radar system and target, the terms PT, G, lambda, stigma are constant. Therefore, the received power PR is inversely proportional to the fourth power of the range R. That is, PR is proportional to 1 by R raised to 4. So, when the target moves away from the radar, increasing R, the received power PR will decrease by the factor of R raised to 4. Next question is, the solar constant is approximately dash. So the solar constant is the amount of the solar electromagnetic radiation received per unit area at the outer edge of the Earth atmosphere on a surface perpendicular to the sun's rays at the average distance between the Earth and sun. Its widely accepted value is 1361 Weber per meter square. This value can vary slightly due to the solar activity and the Earth elliptical orbit. So the options provided include a value of 1368 Weber per meter square. So this is the most appropriate answer. The next question is, the deflection from the vertical of a freely falling particle on Earth can be satisfactorily explained on the basis of dash. Here the answer is Coriolis force. The deflection from the vertical of a freely falling particle on the Earth is caused by the Earth rotation. The Coriolis force is an apparent force that acts on moving objects within a rotating frame of reference such as the Earth. In the northern hemisphere, this force causes object to deflect to the east, and in the southern hemisphere, it deflect to west. So gravity is the primary force causing the fall but not the deflection from the vertical path. So here the answer is Coriolis force. The next question is a vector A is solenoidal if a vector A is defined as solenoidal if its divergence is 0. That means del dot A is equal to 0. So the answer is divergence is 0. Next question is find the eigenvalue of the matrix 1 0 0 0 1 1 0 1 1. So here the matrix given is 1 0 0 0 1 1 0 1 1. So the characteristic equation is determinant of A minus lambda I is equal to 0. That is determinant of 1 minus lambda 0 0 0 1 minus lambda 1 0 1 1 minus lambda is equal to 0. That is 1 minus lambda into determinant of 1 minus lambda 1 1 1 minus lambda minus 0 plus 0 is equal to 0. That is 1 minus lambda into 1 minus lambda into 1 minus lambda into 1 into 1 is equal to 0. That is 1 minus lambda into 1 minus lambda the whole square minus 1 equal to 0. That is 1 minus lambda into 1 minus 2 lambda plus lambda square minus 1 is equal to 0. That is 1 minus lambda into lambda square minus 2 lambda is equal to 0. That is 1 minus lambda into lambda minus 2 is equal to 0. So the roots of this equation is, that means the eigenvalue is lambda equal to 1, 0 and 2. So this is the answer. Next question is the main cause for the seasons to occur is dash. Here the answer is the tilt of Earth's spin axis with respect to orbital plane. The Earth axis is tilted at an angle of about 23.5 degree relative to its orbital plane around the Sun. This tilt means that different parts of the Earth receive more direct light at different times of year. When a hemisphere is tilted towards the Sun, it experiences summer due to the longer days and more direct solar radiation. When an hemisphere is tilted away from the Sun, it experiences winter due to shorter days and less direct solar radiation. The change in distance between the Earth and the Sun throughout the year has a minimal effect on season compared to the axial tilt. The next question is, if water is used instead of mercury in a barometer, the approximate height of water column under standard atmospheric condition will be dash. So, we need to understand the principle of barometer here. We know the pressure exerted by a fluid column in a barometer is given by the formula P is equal to rho GH. Under the standard atmospheric condition, the atmospheric pressure is 1.013 into 10 power 5 Pascal and the density of mercury is rho is equal to 13600 kg per meter cube and the standard height is 0.76 meter. The atmospheric pressure remains the same regardless of the fluid used. That is, P is equal to rho Hg Gh Hg is equal to rho water Gh water. The density of water is 1000 kg per meter cube. So we can write rho H water is equal to rho H Hg. That is, H water is equal to rho Hg H Hg by rho water. Therefore, H water is equal to 13600 kg per meter cube into 0.76 meter divided by 1000 kg per meter cube. And this is equal to 10.336 meter. Converting this to centimeter, we can write 10.336 into 100 and this is approximately equal to 1033.6 centimeter. That is, it is approximately equal to 1000 centimeter. The next question is, if a wave undergoes refraction, what happens to its phase? So here the answer is no phase change will occur, because when a wave undergoes refraction, which is the change in direction as it passes from one medium to another, there is no change in its phase. A phase change of 180 degree occurs only when a wave is reflected from a denser medium. That means a medium having higher refractive index. So here the answer is no phase change will occur. Next question is, a cubical shaped body with 1 meter length on each side when it is at rest moves with the velocity 0.6 c, where c is the velocity of light along x direction. The dimensions of the body noted by an observer on the ground will be dash. That means here we need to find the ratio x is to y is to z. Here the rest length of the cube is L0 is equal to 1 meter and the velocity is 0.6 c. The formula used here is the formula of length contraction, that is L is equal to L0 square root over 1 minus V square by C square. So here the Lorentz factor gamma is equal to 1 by square root over 1 minus V square by C square. That is V by C is equal to 0.6. That is V square by C square is equal to 0.60 whole square, that is equal to 0.36. Therefore 1 minus V square by C square is equal to 1 minus 0.36. This is equal to 0.64. Therefore square root over 1 minus V square by C square is equal to square root over 0.64, that is equal to 0.8. Here the new length is in the x direction, that is Lx is equal to L0 into square root over 1 minus V square by C square, that is equal to 1 meter into 0.8, that is equal to 0.8 meter. The length in the y and the z direction is Ly is equal to L0 is equal to 1 meter, Lz is equal to L0 is equal to 1 meter. So the ratio x is to y is to z is equal to 0.8 is to 1 is to 1. That is option A is the answer. The next question is, water leaves vertically upwards to a height of 8 meter from a fountain of 5 millimeter orifice. The speed of water at the orifice end is dash. By the principle of conservation of energy, we can write half mv square is equal to mgh. That is half v square is equal to gh. That is, we know v square is equal to 2gh, that is v is equal to square root over 2gh. Here h is equal to 8 meter, g is equal to 9.8, that is v is equal to square root over 2 into 9.8 into 8, and this is equal to square root over 156.8. That is v is equal to 12.52 meter per second. Next question is, Weber per meter square is equal to, Weber is the SI unit of magnetic flux and Weber per meter square is the SI unit of magnetic flux density or magnetic field strength. And also Tesla is the SI unit for magnetic flux density. So we can say 1 Weber per meter square is equal to 1 Tesla. Next question is, germanium and copper are cooled to 70 Kelvin from room temperature, then resistance of dash. Here the answer is copper decreases while that of germanium increases. We know copper is a metallic conductor that has the positive temperature coefficient of resistance. That means the resistance decreases as the temperature decreases. But for germanium, it has the negative temperature coefficient of resistance. That means resistance increases as temperature decreases. Therefore, when cooled from room temperature to 70 Kelvin, the resistance of the copper decreases while that of germanium increases. Next question is, the focal length of a convex lens is minimum for dash light. Here the answer is violet. The focal length of a lens is inversely proportional to the refractive index of the material for a specific color of light. The refractive index is highest for violet light and lowest for red light. Then by the lens maker formula, we can write 1 by f is equal to 1 minus n into 1 by r1 minus 1 by r2, where f is the focal length, n is the refractive index, r1 and r2 are the radii of curvature. Since the refractive index n is maximum for violet light, the focal length f will be minimum for violet light. So the answer is violet. The next question is, a train of 150 meter length is going towards north direction at a speed of 10 meter per second. A bird flies at a speed of 5 meter per second towards south direction parallel to the railway track. The time taken by the bird to cross the train is equal to dash. So here the train and the bird are moving in the opposite direction. So the relative speed is the sum of their speed. That means the relative speed is equal to the speed of the train plus the speed of the bird. So the relative speed is equal to 10 plus pi, that is equal to 50 meter per second. The time taken for the bird to cross the train is the length of the train divided by the relative speed. That is the 150 divided by 50. Therefore time is equal to 10 seconds. So the answer is 10 seconds. Next question is, when sound travels through air, the air particles. Here the answer is, it vibrates along the direction of wave propagation. The sound waves are the longitudinal waves when traveling through air. In a longitudinal wave, the particles of the medium vibrate back and forth parallel to the direction of wave's energy propagation. This creates the energy of compression and the rarefaction as the wave moves through the air. So here the answer is, it vibrates along the direction of wave propagation. Next question is, in radio waves, VHF band is The very high frequency VHF band is defined as the range of radio frequencies from 30 MHz to 300 MHz. This range is commonly used for FM radio broadcasting and television broadcasting. So here the answer is 30 to 300 MHz. Next question is the dimension of light year is dash. Light year is a unit of distance, not time. It is defined as the distance that light travels in 1 year. Since the dimension of distance is length, it is represented by L. The dimension of light year is L. So here the answer is L. Next question is the hottest planet in our solar system is dash. Here the answer is Venus. While Mercury is the planet closest to Sun, Venus is the hottest planet in our solar system. This is due to its extremely dense atmosphere, which is full of greenhouse gases, mostly carbon dioxide. This atmosphere traps heat in a runaway greenhouse effect, making the surface temperature hotter than Mercury's, reaching an average of around 464 degrees Celsius. The next question is the emissivity of a body will be dash. Answer is it is between 0 and 1. Emissivity is defined as the ratio of thermal radiation from a surface to the radiation from an ideal black body at the same temperature. A black body has an emissivity of 1 while a perfect reflector has an emissivity of 0. Therefore, for any real body, the emissivity is a dimensionless number that falls between 0 and 1. The next question is for a normal distribution having a mean value of m and standard deviation of sigma, the fractional area under the normal distribution curve within the range of m plus or minus sigma is dash. Here the answer is 68%. According to the empirical rule for a normal distribution, approximately 68% of the data falls within one standard deviation of the mean. The question asks for the area within the range of m plus or minus sigma, which corresponds to this one standard deviation range. So here the answer is 68%. The next question is the melting point of ice is dash. Here the answer is it decreases with increases in pressure. For most substance, an increase in pressure leads to an increase in their melting point. But water is or ice is an exception to this rule. When pressure on a piece of ice increases, its melting point decreases. This is because, unlike most substance, water expands when it freezes. According to Le Chatelier's principle, the system adjusts to counteract the change in condition, and increasing the pressure favors the phase with the smaller volume, which in the case of water is the liquid state. This phenomena is known as radiation. Next question is, when lithium is irradiated with the light of wavelength 300 nanometer, the kinetic energy of the ejected electron is 2.95 into 10 power minus 19 joule. The work function of lithium is dash. Here we know that E is equal to Hc by lambda, and lambda given us 300 nanometer. This is equal to 300 into 10 power minus 9 meter. This is equal to 3 into 10 power minus 7 meter. So E is equal to 6.626 into 10 power minus 34 into 3 into 10 power 8 divided by 3 into 10 power minus 7. That is equal to 19.878 into 10 power minus 26 divided by 3 into 10 power minus 7. And this is equal to 6.626 into 10 power minus 19 joule. And we know E is equal to 5 plus Ke. This is because of the photoelectric effect, because it states that the energy of the instant photon E is equal to the work function of the metal and the maximum of the kinetic energy of the ejected electron. That is E is equal to 5 plus Ke. That is pi is equal to E minus Ke. Here it is given that Ke is equal to 2.95 into 10 power minus 19 joule. That is pi is equal to 6.626 into 10 power minus 19 minus 2.95 into 10 power minus 19. And this is approximately equal to 3.676 into 10 power minus 90 joule. So the answer is 3.67 into 10 power minus 90 joule. The next question is, in a Young's double slit experiment, the slits are separated by 0.28 millimeter and the screen is placed 1.4 meter away. The distance between the central bright fringe and the fourth bright fringe is 1.2 centimeter. The wavelength of the light used in the experiment is dash. Here the slit separation D is equal to 0.28 millimeter, that is equal to 0.28 into 10 power minus 3 meter, and the screen distance L is equal to 1.4 meter. Then the distance to the fourth bright fringe Y4 is equal to 1.2 centimeter, and this is equal to 1.2 into 10 power minus 2 meter. Then the order of fringe N is equal to 4. Then by the position of nth bright fringe in the Young's double slit experiment is Yn is equal to n lambda L by D, where lambda is the wavelength of light. Rearranging this, we get lambda is equal to Yn D by NL, that is 1.2 into 10 power minus 2 into 0.28 into 10 power minus 3 divided by 4 into 1.4, that is equal to 3.36 into 10 power minus 6 divided by 5.6, and this is equal to 0.6 into 10 power minus 6 meter. And this is equal to 0.6 into 10 power minus 6 meter into 10 power 9 nanometer divided by 1 meter, and this is equal to 600 nanometer. So the answer is 600 nanometer. The next question is, a convex lens has 20 centimeter focal length in air. The refractive index of air, water and air glass are 1.33 and 1.5 respectively. The focal length of the above convex lens in water is dash. So here by the lens maker's formula, 1 by f is equal to n lens by n medium minus 1 into 1 by r1 minus 1 by r2. F air is equal to 20 centimeter. And n glass is equal to 1.5, n air is equal to 1. Let C is equal to 1 by R1 minus 1 by R2. We can write 1 by F air is equal to n glass by n air minus 1 into C. Therefore, 1 by 20 is equal to 1.5 by 1 minus 1 into C. That is 1 by 20 is equal to 0.5 C. That is C is equal to 1 by 10. Here it is given that n water is equal to 1.33, n glass is equal to 1.5, C is equal to 1 by 10. Therefore, 1 by F water is equal to n glass by n water minus 1 into C. That is 1 by F water is equal to 1.5 divided by 1.33 minus 1 into 1 by 10. That is 1 by F water is approximately equal to 1.1278 minus 1 into 1 by 10. That is 1 by F water is approximately equal to 0.1278 into 1 by 10. That is 1 by F water is approximately equal to 0.1278 divided by 10. That is F water is equal to 10 divided by 0.1278, and this is approximately equal to 78.25 centimeter. So this is the answer. Next question is, if a magnet is broken into two pieces, each piece possesses two poles. The strength of the new pole is dash. Here the answer is, it is same as the poles of the original magnet. When a magnet is broken into two pieces, each pieces become a new smaller magnet with both a north and south pole. The strength of these two poles remains the same as the poles of the original magnet because magnetism is a fundamental property distributed throughout the material, not concentrated at the ends. Breaking the magnet simply creates new identical poles at the point of break. Next question is, the curl of the vector A is equal to Z I cap plus X j cap plus Y k cap. Given that A is equal to Z I cap plus X j cap plus Y k cap, that is P is equal to Z, Q is equal to X, R is equal to Y. Then the curl del cross A is equal to I j k dou by dou X, dou by dou Y, dou by dou Z, P Q R. That is dou R by dou Y is equal to dou by dou Y of Y is equal to 1, dou Q by dou Z is equal to dou by dou Z of X is equal to 0, dou R by dou X is equal to dou by dou X of Y is equal to 0, dou P by dou Z is equal to dou by dou Z of Z is equal to 1, dou Q by dou X is equal to dou by dou X of X is equal to 1, dou P by dou Y is equal to dou by dou Y of Z is equal to 0. Therefore, del cross A is equal to I into 1 minus 0 minus j into 0 minus 1 plus k into 1 minus 0. That is del cross A is equal to I plus j plus k. So the answer is I plus j plus k. Next question is, in the binary system, the number 12 is written as dash. Here we need to find the binary equivalent of the decimal number 12. So we need to divide 12 with the number 2. Because 2 is the base number of binary number. So 12 by 2 gives the answer 6 with the remainder 0. 6 by 2 gives the answer 3 with the remainder 0. 3 by 2 gives the answer 1 with the remainder 1. 1 by 2 gives the answer 0 with the remainder 1. Then start to write from the lower digit, that is 0, 1, 1, 0, 0 with the base value 2. That is, this is equal to 1, 1, 0, 0 with the base value 2. Next question is, the circumference of the earth was first estimated by dash. Here the answer is Eratosthenes. Eratosthenes, a Greek philosopher and a mathematician, is credited with the first reasonably accurate calculation of Earth's circumference around 240 BC. He used a clever method involving the angle of sun's rays at two different locations at the same time of day and the known distance between them. The other option given are Isaac Newton, Galileo and Copernicus. Copernicus is known for proposing the heliocentric model of solar system, and Galileo made contributions to astronomy and physics. Isaac Newton is known for his law of motion and universal gravitation. So here the answer is Eratosthenes. The next question is, which of the following reasons explain why the stratosphere is absolutely stable? The stratosphere is characterized by an increase in temperature with altitude, which is due to the absorption of solar ultraviolet radiation by the ozone layer. This vertical stratification with warmer layers above and colder layers below makes the stratosphere dynamically stable, as there is no regular convection and related turbulence in the troposphere. So here the answer is option C. Next question is, find the odd one out. Here the answer is Soyuz. Skylab, Salyut and Tiangong are all the names of space station or laboratories launched by the different nations. While Soyuz, on the other hand, it is a type of spacecraft used to transport cosmonauts to and from space station. It is not a space station itself. The next question is, the Russian Space Agency responsible for the wide range and types of space flights and cosmonautics programs for the Federation. So here the answer is Roscosmos. It is the governmental body responsible for the wide range and the types of space flight and cosmonautics program for Russian Federation. The next question is, which English astronomer provided confirmation of relativity through observations during the solar eclipse of 29 May 1990? The answer is Arthur Eddington. He observed the apparent bending of starlight around the sun's gravitational field, which confirmed the Einstein predictions. The next question is, the value of golden ratio is dash. The answer is 1.618. The golden ratio, often represented by Greek letter phi, is an irrational mathematical constant approximately equal to 1.61803398887. The next question is, which of the following air masses is the most dense? Here the answer is cold and dry. Air masses are large bodies of air with relative uniform temperature and moisture characteristics. The density of air is determined by both its temperature and moisture content. We know for temperature, the colder air is denser than the warmer air because its molecules are packed more closely together. And for moisture, dry air is denser than moist air. Water vapor has a lower molecular weight than the average molecular weight of dry air. Therefore, an air mass that is both cold and dry will be the most dense, and an air mass that is warm and moist will be the least dense. The next question is, the dense planet of the solar system is dash. The answer is Earth. Earth is the densest planet in the solar system with an average density of 5.51 grams per cubic centimeter. This high density is due to its composition of a dense metallic core and rocky mantle. The Mercury is the second densest planet. The other option, Uranus and Jupiter, are gas or ice giants and have much lower densities compared to terrestrial planets. Next question is the type of nozzle used in a typical rocket engine is dash. The answer is convergent divergent. A convergent divergent nozzle, often a D level type, is used in rocket engines to accelerate the exhaust gases from subsonic speed through the speed of sound at the throat to supersonic velocities at the exit. The converging section increases the velocity of the fluid and the subsequent divergent section further increases the velocity to achieve maximum thrust. So here the answer is convergent divergent. Next question is which of the following software can be used to generate interactive animated contents to explain scientific principle? The answer is Adobe Flash. Adobe Flash is a multimedia software platform specifically designed for producing animations and interactive web applications. This is the end of this video. Thanks for watching this channel.